First of all, I want to thank you all for coming to this talk. I know it's not an usual talk in a C++ language conference. Maybe we are not used to talks about DevOps or CIs, but these things are getting hotter and hotter in the software development world, and we have to take them into account. So the clicker was not working. I need to approach the computer from time to time to just pass the slides. My name is Javier Garcia Sogo. I'm working in a package manager in Spain. I'm working in Conan. We have the booth just outside this room. And I think that if you are here, it's because you are concerned about the ABI compatibility problem, or maybe you are suffering it in your companies, or you want to know how can help you other tools to deal with this problem. In C++, we are building native applications, so we have to take care of ABI compatibility. And I think that it's not a major problem. It's a problem we have in all the software development world. And the aim of this talk is to try to convince you that it's not as big as we usually think. Because right now, if I ask you to raise your hand, who thinks that ABI compatibility is a big problem, maybe if you are not too shy, maybe a couple of people will raise the hand for sure. So before beginning the talk, I want to thank all the sponsors, the organizers of the conference, the venue. I think we are in a great place to have a conference here in Italy. We, at least the Conan team, we want to thank Marco and all the organizers for making this possible and for making this free event. Before entering the topic, just a couple of definitions in order to know what we are talking about. So first of all, this talk is about ABI, not API. API stands for Application Programming Interface, which according to the dictionary is a set of functions and data that a library provides. Okay? I like to think about it like a contract. There are some things of this contract that are ensured by the compiler or even by the language, and other things that the compiler cannot check, and we have to rely on the documentations. Here I have a screenshot from cppReference.com. I suppose all of you know this webpage and are using it to check these kind of contracts. Here we can find the name of the function, std_apply. We know which header we have to include, tuple. We know the number of arguments the function is taken, the type of the arguments. Maybe this is not the best example if we want to know the type of the arguments, but you know, that's what I have here, the return type. And the part that cannot be ensured by the compiler of the language or the language, which is what this function does. We have to go to the documentation and read, okay, this function is invoking the callable object f with a tuple of arguments. That's fine. On the other hand, we have ABI, which stands for Application Binary Interface, which is a much low-level, almost machine code. And the application binary interface, it is the interface between two binary program modules. Okay, let's think about modules like in the general sense, not about the C++20 modules Dimitri is talking about in the other room. This is something that is not standardized in the language, and I think it won't ever be. Why? First of all, the committee, the C++ standard, takes care of the language, not about the implementation. And also, you know that different compilers generate different ABIs, so at this moment, we cannot standardize it because we have to choose one, and it will be a huge competitive advantage for that company. So we have to live with a non-standard ABI. And the ABI can be affected by many different things. I'm grouping them into two categories. The first one is where the code is generated and where it is going to run, the production environment and the compiler environment. And here we can find things like the calling convention. You know, if the arguments to the functions are going to be passed using registries or in the stack, who has to free the memory afterwards. So the exception handling, when our code raises an exception, the operating system needs to know how to look for a function that takes care of that exception, how to delete intermediate objects, how to delegate the flow of the program into that function. More things, name mangling. You know, the name mangling is the mapping between the names in the source code and the names that the linker is using. And those name mangling is different with different compilers. And also the runtime. The operating system is providing our programs with utilities and functions, very basic ones, but those functions are different, have a different ABI depending on the operating system, the distribution, or the platform we are using. And the other group that affect our ABI is more on the developer side, which are things like the binary representation of types. Okay, the developer cannot change that representation, but we as developers can choose which types to use. And also many things in the C++ language, like inheritance, namespaces, overloading of functions, everything that, all of those things affect the ABI. And what I want to tell you is that if the ABI can change, it makes sense to talk about binary compatibility, binary stability, about stable binary interfaces. And we can come up with these definitions. A library is binary compatible if another module of our program, another application, is able to run with a new version of the library without the need of linking again. You just take the new version, copy there in the file system, and it runs. And it is different from source compatibility. You already know that a library is source compatible with a previous version if you need to compile again and to link again, but you don't need to modify your sources. The reason I'm talking to you about all of this is because I'm working at JFrog as a software engineer, and you may know that JFrog is a company that takes care of all the life cycle of your binaries. I'm sure you are already using Artifactory, which is the main product of JFrog, which is not only a binary database, but a full ecosystem trying to cover all the life cycle from the commit to the deployment to devices, to all the places where your binaries are running. Inside JFrog, I work in the community and partnership division, where we are developing tools for the community, like the Go Center, which is a central repository for Go modules, Bintray, which is a service to host binaries, and also Conan, which is a package manager for C++. I've been working in C++ for more than 10 years, and as you all, I love this language, but I also hate it. Some things are quite complicated. It's so hard to reuse existing code, to reuse libraries. And some years ago, I moved to other languages like Python or JavaScript, and I discovered the package managers, and it was amazing. You just need to install or to import a module, and then you start writing your own code, your application. And I dreamed about a world where you can make prototypes in C++, where you can choose a library, OpenCV, and then I want to make a face recognition prototype. I just look for an example, can write a couple of lines of code, and I don't need to deal with libraries. And looking in internet, I found two guys from Madrid who were working in a package manager, and I fall in love with the project, and now I'm working on it, trying to solve this pain for all of you. You can find us in GitHub, because itCppCon19 is an open source project. MIT license is free. You can use it, you can fork it, and implement on top of it whatever you want. And also, we are very active in the community, in the Slack channel, and also in Twitter. Right now, we are 7 barbarians. 5 of us are in Madrid. One is working remotely from Russia, and another one from Brazil. And we are trying to grow. So if any one of you is interested, please let me know, and we can make a deal. And also, this is about a C++ community. I'm organizing the community in Madrid. We don't have an international conference. Okay, we have one, but it's not by the community like this one. We would like to have a greater event in Madrid. So if you go there, or you are willing for a conference in Madrid, just let me know, and we'll try to make it happen. But okay, let's come back to the topic. I'm sure you know this picture. This is by Pablo Picasso. It's probably one of the most famous masterpieces we have in Spain, but I don't know if you know what motivated the picture. No, this is a runtime error. You know, you can see the customer shouting, the manager is looking for someone to blame, the DevOps guy is hiding, everything. That's a complete chaos. And it was not the bombing of a city in the north of Spain. You know, it was just a runtime error, and a very hard one we had in Spain just before the Second World War. Okay, up to now, with the things I have told you, probably ABI compatibility is a major problem. But during this talk, I'm trying to change your mind. In C++, we are moving between two extremes. One of those extremes is writing a monolithic application, compiling everything from sources, all the code in the same repo, and it has many drawbacks. You are compiling everything from again and again, all your team is compiling the same, and it's so boring. But it's cool. You don't have to care about ABI compatibility unless you allow plugins in your application, because plugins will have a different release cycle, and you need to keep ABI compatibility for them. And in the opposite side, it is a library. We as developers, if we are in a language conference, probably we do like libraries. We do like writing libraries. And if you want to sell your binaries just because licenses or because intellectual properties, you need to care about ABI compatibility. You don't want to break your customers. Remember the picture? Okay. You may think, hey, but I write header-onlys. I'm a meta-programmer guy. Okay, if you want me to use your cool template library, your header-only in my library, I may need to expose some of your types. So I will want you to take care of ABI compatibility. Otherwise, you are polluting my ABI, and I will blame you, and finally, I won't use your library. So please, don't be a troll. Take care of ABI compatibility always. There are many things that can affect the ABI compatibility. So let's see some examples. This is like a monolithic application, a really old one. It's C plain code. I had to look for it in internet. I can no longer write these cryptic things. And who thinks that here we can have an ABI problem? You think this program is just listing the files inside the current directory? Do you think we are facing a runtime error? Yes, it can be. Why? Because of the standard library. The C runtime is provided by the operating system, and there are different C libraries. As you can see, I have here a table with 4 with different properties. Some of them are focusing in binary size, others in performance, others are solving some bugs. But if you run your application, at the bottom of the slides, there are 3 different ranges in different environments. You can find different runtime errors. The first one, I was compiling with glibc, I think, and then running in Alpine Linux, which use musl, and you see, it was not working. At least it tells me that the application couldn't find the musl standard library. The second one, I can't remember what was the problem. But if it happens for one of your customers and it says, okay, this is all I have, fix it, please. I need this application running tomorrow. You don't know what to do. And in the third use case, I just link with a different version, and he is complaining because the version is not the same, probably because I compile with a newer version. Yes, because these standard libraries evolve in time. They are releasing new versions from time to time. The most famous one is the glibc, which stands for GNU C library. They claim to be backwards compatible, which means that, as we've seen before, that if you link with an older version, you are able to run with newer versions. And that's one of the strategies you can use to make binaries more compatible. You can go to an old version, like the one used in a CentOS 6, link there your application, and then you can distribute it, and it will work with newer versions, because it is backward compatible, unless from time to time they remove some functions. Who cares? Nevertheless, even if it works, be careful, because you are not using, maybe they are fixing some bugs. So if you link with an old version, the code that is maybe inlined won't be in your application. And also, there are things that are not stable, are not documented as stable. And that was a problem I read about in an email chain from TripAdvisor. They were using PostgreSQL, the database. They compile it in an old system and distribute in all systems, but not the same versions. And it happens that when they query the database, they obtain different results in different order. The same results, but with different order. And it was because the collation ordering for Unicode changed from, it's not stable, was changing from one version to another. And it was a painful problem. So be careful. We can deal with this kind of ABI compatibility issue, but we have to know about it. Other challenger we have to face is the tooling ecosystems. We are writing C++, we need a compiler for sure. And from time to time, these compilers are releasing new versions because they have to support new functionalities, new versions of the standard, whatever. And they are changing the ABI. Sometimes it is a bug, like the one they introduced in 4.7. Other times it's necessary, like the change to GCC 5 when the C++ 11 was introduced. You know that the ABI of the STD string changes, so the STD string is more or less everywhere in the standard library, so they need to do something. And to deal with this change, they use the inline namespaces feature. Let's see in this slide. They use the inline namespaces feature, which is also a C++ 11 feature. that allows you to have more than one ABI in the same library. It is called the dual ABI. And then it's the developer, the linker, the one who chooses which version to link. So from version 5 onwards, we can choose the ABI to link using that macro I have in that snippet. So if you use the previous version, even if you try to activate the macro, you get the old ABI. You have there the line, and it's nothing related to C++11. But after 5, if you use a newer compiler with the macro set to 1, you get the C++11 ABI. And if you set the macro to 0 or to false or that kind of stuff, then you get the old ABI. So it's something you as developer can deal with it depending on your target platform or your application or what are you going to link this library with. But it's not so easy sometimes. Here I have an example. I'm trying to link with the new ABI. I'm using an old distribution of Ubuntu and using a new compiler. And what do I get? I get the old ABI. Because that version of the distribution doesn't have the dual ABI. So they decided that the compiler should generate always binaries for the old ABI. Know it, because it was a pain for us in Conan, because in Travis they were using we generate binaries, we use Travis, it was an old distribution, people was trying to use new compilers, and they keep generating old ABIs. So, something to take into account. For sure, every compiler evolves, the same from Microsoft Visual Studio. They released this year 2019, I suppose all of you know. And the important thing is not the year of the Microsoft Visual Studio, but the toolset. Okay? If you read the release notes, it says that the new toolset, the 14.2, is compatible with the old ones of the same major version of the 14 series. So we can have different scenarios. On your left, the first scenario, it's not going to work. Maybe it works if we don't use only very basic types, but in the general case, it's not going to work. We are not using the same toolchain. The next scenario, if we use the same toolchain, it is going to work. And the other two ones maybe work, maybe not. According to the release notes, they should work. But if you keep reading in the documentations, you find that, okay, it works only if you link with the oldest toolset, with the last toolset, sorry. I put an exclamation on the right because, to be honest, I've run several tests. They said that it's not compatible, but it always worked for me. So maybe they don't make that commitment, but they just want to keep the freedom of breaking in the future. And this is something important to take into account. It's not only the compiler, but also the version or maybe the toolset. So up to now, we have seen that the operating system affects our ABI and also the tooling ecosystem. Let's move on. Also, as everybody can imagine, sources will affect our ABI. Just let me show very basic examples. This is, for a C++ conference, these are toys. So here I have a library which provides a function implemented in the CPP file, and another function, an inline one. The application is just calling a function first, then the other one, and printing the result. If I change the implementation of the function which is defined in the CPP file, I get the new result. That's the reason we are using dynamic libraries to make these kind of things, to change the behavior without the need of compiling it again. Okay, that's cool. Now I'm changing a default value in the first function, the one which was implemented in the CPP file, and I'm also modifying the name of the inline function. Okay, it's like removing the function and adding a different one. And I get the same result as before. That's why the inline code is embedded into the consumer. And that's very important because to have it in mind, because if you have an inline function, it's going to be in the consumer, and you have to pay attention that if that function is calling a private function, then the private function will be also in the ABI. We all know that private functions are not in the ABI unless they are called from an inline function. Also, here I'm changing the function that is implemented in the library, and then I get a runtime error. It's fair, it's nice. I like this kind of errors. More examples. A library that is providing a data type that sum with two members, A and B, and two functions, the same idea, returning the sum of the members of the data type. Just I compile, I link, I compile the application linking with that library, and I get 20 for both functions. What can I do now? If I change the data type, adding one extra member, and I modify the functions, I compile the library. Okay, in all these examples, I'm not linking again. I'm trying to see what breaks the ABI. What happens? The first function returns an undefined behavior. Why? Because the data type I'm providing to the library doesn't have the last member, the third one, and then it is uninitialized and it's summing just trash, and it is returning undefined behavior. But the other one, as it is embedded into the consumer, it is still working as expected. This is not making me so happy. I sometimes prefer a runtime error than returning an invalid value, but this is what we have. And another example, this is a tricky one. Okay, I have an string as a member of the data type that the library is providing, and then an application which is using that data type. Depending on the if clause, on the branch in runtime, it's going to use the object I'm creating, or it is going to say hi to the argument I'm using when calling the application. So without any argument, it says hello Manuel. Without an argument, it says hello Javier. Let's see what happens if I modify the data type. If I remove that string, I get a segmentation fault, which is a really awful error for one of the branches of the if condition, and it works for the other one. And this scares me because if we don't have full coverage in the tests, probably we are not running the one who is failing. We are running the one who works, and we are not going to realize about it until our customer, the one who is paying more for our library, says, hey, it's broken. And maybe you have to go back in time. You don't know in which commit you introduce that AB change. So careful. And the fourth thing I want to show you is that the environment where the application is going to run can affect the way you handle your binaries. So if you work in a company, probably you have your concept, your architecture is something like this. You have an operating system layer with the C runtime or in the C++ one, maybe some drivers. On top of it, you have third parties. You have bought to some vendors. On top of it, you build your business logic, your libraries, your framework, and then you build applications that use those libraries. At some point in time, you are building another application and you are requiring another third party. That's fine, everything works, the graph is nice. But now that you have that third party, one of your libraries is going to use it. Why not? I have it, just use it. And in the future, probably you evolve the application and you need a different versions of your third party. What happens? Maybe it's not ABI compatible with the previous one, and then you start to have a problem. Because you will want the first application to use that new version, but you can't. And things always go worse until you get the runtime error. If it's you, the one who gets the runtime error, it's okay, but usually it's not you, but the customer who is paying you. So what do? You can split your application into isolated boxes, so into different directories, and you copy into the directory all the dependencies, all the shared libraries with the version your application is using. And it's okay, it's not going to have any problem. I think that this is the reason why Docker is so successful these days, right? But now you are introducing a new problem you don't have until now. Is that you have to identify, now you have several libraries, many, that have the same name but are not exactly the same. So you have to identify all of them. And the problem is that if you find a bug in one of them, you have to apply the patch, compile all those libraries using the same flags, everything the same, because you don't want to break the ABI. You just want to patch the bug. And it's not so, okay, it's easy. Conceptually, it's very easy, but it starts to be a problem of how you manage it. But it will work. You can apply your patch, you submit the commit to the CI workflow, you relax, and nice, nothing is going to happen. But as we have seen, your customers are using your libraries in so many different scenarios, and something can happen and wake you up. But from now on, I think that it's not a major problem. If you know what can affect your ABI, it's not a major problem, but it's a problem of how to deal with all those binaries. So let's recap a little bit. What can affect the ABI? The sources, we have said. So you have to identify them. It's easy. Just give your library a name, use some kind of versioning, maybe identify, like in GitHub, who is the owner of the repository, which branch are you using, and this is what in Conan we name a Conan reference. It's just those 4 keywords. Move on. List all the environments where your binary is going to run. And of course, if those environments that requires different binaries. Just here I'm listing some of them. You can, maybe it's important to differentiate between Windows, Linux, MacOS, but also between the versions of those systems. List them. Your toolings. As we have seen, the compiler is important, and also the version of the compilers, and maybe some flags associated with the way the compiler is generating your binaries, which is like the standard you are using, or if you are compiling a shared library or a static one, or the toolset, whatever you feel like it's important for your binaries, put it there. And other flags, other things that can affect your binaries. Not only the CPP standard or the build type, but also some options your library may have. Activate this feature, and then it will generate a different binary. List all of them. What do we have in the picture? What we were talking about before. We have now a combinatorial explosion, okay, because potentially each combination of each of these things can generate a different binary, and those are many different combinations. For example, we are just scratching the surface in Conan, and we are generating some binaries for some libraries, and we do it 200 different binaries, just with the most common compilers and versions. But things are even worse. If you realize that libraries has dependencies, and each binary of each library can be combined with each binary of each other library. Okay, maybe some combinations doesn't make sense, but you have a graph, the graph is getting bigger and bigger in a real project, and this is a combinatorial explosion. These are thousands, myriads of binaries. But it's not, the problem is not getting complex, it's just, the problem is how to deal with all these combinations. Not big deal. We have the sources, we have our machinery, we know how to build using those settings. We can associate the produced binary to those settings, generate a unique ID, and upload the binary to a database. That's all. Then, if a customer wants to buy our library, he will tell us, I want to buy the binaries for this compiler, these versions. You can go to your database, generate the ID again, and retrieve the binaries. Put it in a box, and deliver to the Docker container your customer is going to use. So, come on, just let put your worker to build an in-house solution. Allocate some time, some resources, spend money, and after some months, maybe someone from outside your company or from inside your company will tell you, hey, I found this. We have been wasting our time. Stop. There is people already working on this. And yes, these people is the Conan team, and okay, you know, we work with JFrog, so also as a server you have to use Artifactory. In this context, you can think of Artifactory just as a binary database to store the binaries and the configuration associated to it, and Conan will be just an SQL manager. Conan will convert your settings into a unique ID and will be able to find the matching row into the Artifactory database and update that binary or retrieve the binary. And this is one of the main features of Conan, a really simple one, but it's the principle we use to handle these ABI compatibility issues. Imagine you, by default, you have one configuration. So we have a command in Conan, it's called info, that generates the ID, that tells you the ID Conan is going to generate for that configuration. So if you modify the configuration, it will generate different IDs. And this all is possible because you need, like it is on the right side, you need a recipe for each library you want to use with Conan, where you declare the things we have seen before, the name of the library, the versions, the settings that affect your library. We had those big lists of operating systems and versions. Here we just need to declare my binaries are different if the operating system is different, if the compiler is different, my binaries are different if the option shard is true or if the option is false. And then Conan just will generate different IDs for each combination. And the other way around, if you have the reference and you have the ID, you can use Conan to query how that binary was generated. And you can see here an example of a query for setlib. I'm not using the query expression, just showing a couple of package IDs and the configuration we use to generate it. But this is not a talk about Conan, so if you want to know more, just go to our booth. If you want a t-shirt, you can pass a very easy survey or test, get the t-shirt. You can find us in GitHub, in Slack, in Twitter, and we are also going to be in all these conferences this year. So next week, we will be in SwampUp, and also we are going to be in CppCon, in Codemotion in Madrid, and in Berlin, for sure, in Meeting Embedded and Meeting C++. So we are easy to find. So I think that with all I have told you, ABI compatibility is not a major problem. It's just you have to use the right tool to solve that problem. And this is what I wanted to tell you. So thanks, grazie mille. I think we have some time for a couple of questions. So if anyone have any question. I don't know if we are using a microphone or. Yeah, maybe.
So, in the case of the type dependency, where you show the slide with the library, in case you ever need different, let's say, flavors of that Z-Lib library, will Conan be able to advertise that might be something that cannot be done in the system, or like, because it's fine as soon as you keep the same compilation settings for that library on branches that are using that. But if those settings eventually diverge, and you don't have any control on the intermediate libraries, you might not be able to resolve the library again. So will Conan tell us that that's not doable, but you're including some dependencies that are conflicting?
So the question was if, maybe I'll try to reformulate it, if in a big graph, in a project, you can find that there are some combination of the dependencies of the libraries that are not compatible, more or less, okay? So we are building the full graph. So Conan doesn't know in advance if the library is going to compile, right? But you will have all the information. You will know which are the settings that are going to be applied to each of the nodes of the graph. So maybe if you are in a company and your developers are just consuming binaries generated by a CI, you know that if the binary is not available, it's because you cannot, as a developer, use it. So Conan will tell you, this is the graph. Do you want to build this library from sources? Maybe you are overriding some dependencies. Conan will warn you when you try to build the library and says, hey, you are using setlib this version, but you are requiring a different version. You can override it. Nobody has tested it before. It can build or not. It can run or not. Conan cannot tell you about it in advance, but Conan will provide you with all the information, and then you can do with that information. I can't tell you how can you inform your team of developers how to share that information. Don't try to build this because it's not going to work. But you at least have the information. You have all the graph, you know the settings for each of the nodes, and if it was successful or not. Just use the information. Thanks. So the question was if Conan is able to detect binary incompatibility between different versions between two libraries. No. because you don't know if two libraries are compatible until you run with them. No, there is nothing implemented in Conan, and I think that the best thing we can do is just someone tried it before and it was not working. You can override the version, you can override the requirements, you are the first person trying that combination, and Conan is not going to, I don't know, to see all the name mangling and to check if those are matching or not. No, it's not I think it's not our job to do that kind of checks. So, yes, please.
For each library, how do we know what is the dependencies of the libraries?
Here, in the recipe file, here this one doesn't have, maybe I have to improve this example, because in the recipe file you list the requirements. Here maybe I was too focused in setlib, which has no requirements, but if you check the OpenCV one, which is corresponding to this graph, there is a field in the recipe declaring, okay, OpenCV depends on these libraries, and this version of OpenCV depends in that version of those libraries. You can use version ranges and things like that, or maybe include some conditioned to some options, or in Windows use one library and in Linux use a different one, and that's a field in the recipe.
So in your repository, every library has
Yeah, it's a Python class like this. It's a text file. You can store it in a repository next to the sources of your library, or you can store it isolated, as you prefer.
Yeah, nice way for using Conan to generate that kind of nice graph with all the dependencies, so I can see.
Yes, this graph was generated with Conan, and you can also click in the node, and it will tell you the information, this kind of information. Yes, it's like, an amusement for. Yes.
Is the package ID computed on top of all the options and all the settings? Like, and by options, I mean custom-defined ones.
So I realized that I was not repeating the previous questions. So the question was if the package ID is computed on top of the options and settings and so on. Yes, the package ID takes into account the name of the library, the version, the user, the channel, all the settings you are using to generate that binary, all the options, also all the requirements, and we have different behaviors because you might include the versions and the user and the channel of all the requirements and also the transitive requirements. We are able to handle the full graph if you want us to compute different binaries. But then, as soon as you change a colon in a file, you will rebuild everything. And, and we are trying to reduce compilation times. But,
At least you're safe.
yeah, it's in your side. Right. So, please.
Suppose you have an application that is splitting plugins.
Mm-hmm.
So each plugin is a separate project, and the main application will be at runtime. May I use Conan to help me, at least with building the application, prepare for deployment, for example?
So the question is, if I have an application which is using many plugins, or maybe built from plugins, if I can, how Conan match that scenario, right? So I think it's a good match because you can share with your plugin developers a file with all the settings, and you can say, hey, this version of the core of my application, use these settings. Use these settings for your plugins. So you can share with them in a file, not just in a document or written, you can share with them this file is for Windows, for this compiler, with these flags, and if you are using dependencies in your plugins, then I want to override these dependencies. For example, I want all the plugins to use the version 1 of this core library of the framework you are trying to put your plugin into. So you can override and force the user or the developer of the plugin to use some versions that are being in that version of the core framework. So I think it's a good match. I don't know if not, afterwards we can talk outside. I think so. So thanks. I think that if there is no more questions, we are done. So thank you very much. Thank you for coming. Thanks.